So here we're told that n is an integer such that 3n plus 2 is less than or equal to 14, and that 6n over n squared plus 5 is greater than 1. And we're asked to find all of the possible values of n. Now, just to remind me later on in the question, I'm just going to write down that n has to be an integer here. So we're just going to be working with integer value solutions for this. We're not going to be looking at any sort of inequalities later in the question. So as for how I'm going to go about starting this question, we obviously have two inequalities that we're going to work with and find values of n that are going to satisfy both. And working with inequalities, especially with quadratics and linear inequalities, we're probably going to need to sketch these graphs. And in order to aid us with this, simplifying these inequalities and getting them in terms of the unknown, so n in this case, is going to be really helpful when seeing which values of n are going to satisfy them. So if I take the first inequality, so 3n plus 2 is less than or equal to 14, to get this in terms of n, if I firstly subtract 2 from both sides, so that leaves me with 3n on the left, and then 14 minus 2, which is 12, on the right. And then I can simply divide both sides by 3, so n is less than or equal to 12 divided by 3, which is 4 here. And that's basically my first inequality written in terms of n being less than or equal to something. So then working with the second one, the same sort of principles apply here. So 6n over n squared plus 5 is greater than, this time, 1. Now I can multiply both sides by n squared plus 5, and that leaves the left-hand side as simply 6n. And that's 6n being greater than 1 multiplied by n squared plus 5, so n squared plus 5. Now I can see that I'm kind of sort of building a quadratic here. We've got an n squared and a term with n in it. And if I move all of the terms over to one side of the inequality sign, I'm left with basically a quadratic being less than 0. So if I move the 6n to the other side, I have 0 is greater than n squared minus 6n, because I'm subtracting it from both sides, plus 5. Now, in order to find the roots of this equation, so the values of n, the values that basically intersect the n-axis of this graph, which could be basically changed to x, it's the same sort of thing, I'm going to factorise it. I could use the quadratic formula here, but this is going to factorise really nicely. So that's going to leave me with n minus 5 multiplied by n minus 1, and that is the factorised form. Now I can see that if we make either of those equal to 0, the roots of this equation are going to be where n is equal to 5 and n is equal to 1. So basically this holds for values of n between 1 and 5. Now, when I'm working with inequalities, the best idea to go on from here is definitely to sketch the graph in, just so we're 100% sure of what we're working with and where all of these values are going to sit. So if I draw some axes of a graph in, now the y-axis is just going to stay as the y-axis here, but then I'm just going to label the x-axis as n, because that's our unknown variable in this sort of question. So then, working with this inequality to begin with, if we have solutions at n equals 5 and n equals 1, I can just plot those on the n-axis, so n equals 1 and then n equals 5. And we're working here with a positive quadratic because the n squared coefficient is 1, which is positive. So it's going to be a positive quadratic, so like a smiley face, as opposed to a negative quadratic or a frown. So I can just sketch that in. Doesn't matter where the turning point is or anything like that, we just need a rough idea of the inequality. And then also here, I'm looking for where this quadratic is going to be less than 0. So any values of this quadratic that are less than 0. So we take the value for 0 on the y-axis, and we're basically looking at all of these values that sit below the y-axis but aren't equal to it. So 1 and 5 aren't included, but this region here is. So I can write this as an inequality. 1 is less than n, which is less than 5, when working with this inequality we have here. Now similarly, I can now draw in the other line of where n is less than or equal to 4 to see which values of n satisfy both inequalities. So n is less than or equal to 4 is simply going to be a straight line that runs parallel to the y-axis, and this is going to be at the point 4, and we're looking for anything this side of this line, so less than or equal to 4, and it is including 4 here. So now we're looking for the points at which n satisfies both of these inequalities, so the points that sit on this line here but are also to the left of this line n equals 4. So that's going to be this part of the curve here. And I remember that we're looking for integer values in this question. So if I go from 1 to start with, 1's not included because it's just the greater than symbol, it's not greater than or equal to. Moving up, 2 will be included, 2 is less than 4, so is 3. And then moving up still, 4 is going to be included here because it is less than or equal to 4, so we can include 4. However, anything beyond 4, anything greater than 4, so 5, is not going to be included in this inequality because n is not going to be less than or equal to 4. So here we have our 3 integer values, 3 possible integer values that could represent n, and that is going to bring us to the end of this question. Now if I go back to see how the marks were awarded here, we gained the first mark for basically solving the first inequality and getting that in terms of n, so n being less than or equal to 4. And then the second mark for rearranging this inequality here, so multiplying out and getting it in the form of a quadratic, so this quadratic here. And then the next mark was for factorising this, so leaving us with n minus 5, n minus 1. And then for forming some kind of inequality, so for n being greater than 1 and n being less than or equal to 4, or for this inequality that we've written out here. And we've represented this graphically in the diagram that I've drawn up. And then the final mark is going to just be for this correct answer of 2, 3 and 4 as the integer values for n.